So in this problem video, we're going to have two different calculations that you can try. So the first one, how many milliliters of a stock solution of 10.0 molar HNO3 would you have to use to prepare 0.350 liters of 0.400 molar HNO3? Go ahead and pause the video and give that one a try. Okay, let's take a look. Now, notice that these two facts are conjoined. We're saying that we're going to be preparing 0.350 liters of 0.400 molar HNO3. We want to keep these on the same side. Now, if we're setting up an M1V1 equals M2V2 problem, since I'm talking about what I'm preparing, I'd probably call this V2. Or if you prefer subscripts I and F for initial and final, it'd probably be the final one. It really won't matter mathematically, but that's how we usually will organize these things. Now, the reason I'm keeping these together is because we're talking about the same solution, right? Well, up here I have a different solution. I have a concentrated solution, and it's asking how many milliliters of the concentrated solution do I need to use. So let's go ahead and set this one up. We have 0.350 liters times 0.400 molar HNO3. I'm going to leave out the chemical species here because we're only talking about one in this problem. Now on the other side, I'm trying to find out what volume I'm going to prepare with, and it tells me what my concentration is at the very beginning. It's 10.0 molar. So in order to get V1 by itself, I'm going to go ahead and bring 10.0 molar over to this side. So I'm just going to rearrange the equation. So we're ready to grab our calculator, and we can just go ahead and solve for the volume needed. Okay, so let's do that right now. We have 0.350 times 0.400 divided by 10.0, and that's going to be 0.014. V1 equals 0.014 liters. I was asked for milliliters, so I'm going to convert from liters into milliliters. I have 1 liter, one big thing, equals lots of little things. So I'm going to multiply by 1,000. And we do times 1,000. We'll have 14 milliliters needed to prepare that. So 14 milliliters of HNO3. Now let's make sure that we have appropriate sig figs. I have 2 sig figs here. Let's come back up here. So I have 3 sig figs here, 3 here, and 3 here. So that piece should have had 3 sig figs. So let's go ahead and put a 0 in to correct those sig figs. This is an exact relationship, so I need to update this to be 14.0 milliliters of HNO3. Oops. There, as my final answer for this piece. Now I'm going to go ahead and clear the screen so we can try the second one that I just pulled up accidentally. Okay, so let's try the second problem. We have 25.0 milliliters of our stock solution. So this is talking about the stock solution up above, which was this concentration. These two are going to be conjoined. So we're going to dilute that solution to a final volume of 0.500 liters. What's going to be the concentration of that final solution? So let's set that up. We'll have our M1V1 equals M2V2. This is going to be my initial set of conditions, so I'll put that as M1 and V1. So concentration 1, 10.0 molar times 25 milliliters. So let's go ahead and do the conversion from 25.0 milliliters into liters. We have 1,000 little things in one big thing. Milliliters have cross-canceled. I'll divide that by 1,000, also known as moving the decimal 3 places. That answer will be 0.0250. 0.0250 liters equals, now I'm trying to find the concentration, so M2 is the thing that I'm trying to calculate. I'll go ahead and put that right there. Now I'm going to put in my volume, which is 0.500, 0.500 liters. I'm going to bring that to the other side, 0.500 liters, and now I'm ready to grab the calculator in order to determine this one. Okay, so here's our calculator. We're going to have 10.0 times 0.0250 divided by 0.500 gives us 0.5 for our answer for the concentration. So 0.500, to get my sig figs correct, molar will be my final solution calculation.